So taking a look at a retrosynthesis problem, if we're working one step back, first thing you want to look at is notice the relationship between the two substituents. If you notice between them, they're paired to each other. So that means an electron donating group somehow got that to go. And so you look at the two groups. This is an alkyl. That's a carbon of a carbonyl. So this is electron withdrawing. This is electron donating. So this would have to come on at the end, last probably. Then also it's kind of weird too here because this is all of a sudden an OH on the less substituted carbon. So that should also pique your interest too. That reminds you of a reaction that you maybe know. Having that OH on less substituted carbon. That's an anti-Markovnikov product. So that would come from if we had the carbonyl still on there, that would come from this, from an alkene. Then one step back from this would be taking the carbonyl off, carbonyl group off. One step back from this would be probably you don't know ways to add, right? For Friedel-Crafts alkylation, right, and carbocations, right? This carbon right here is sp2 hybridized, so that had to come from an elimination though. So one more step back would be a little ugly benzene ring there. The bromine there. I'm gonna run out of room here. Sorry. So I'm not done yet. I'm still at this, which could have came from that, which could have came from the benzene ring. Going forward with this is a Friedel-Crafts alkylation, right? Because Friedel-Crafts alkylations only involve sp3 hybridized carbons. So it would be a chlorine, and I need 2 carbon pieces in AlCl3. That's a catalyst. Here I need bromination, so that's that MBS in the benzylic position. If I zoom back in over here, right, back there, do this, I need a large bulky base, maybe something like LDA, lithium, diisopropylamine. Any sort of bulky reactive base would do that. Friedel-Crafts acylation, I need the chlorine, and I need that ketone and AlCl3 again, which is a catalyst. And then here to have that add anti-Markovnikov, I need that BH3 and NaOH, and that gives me that anti-Markovnikov alcohol addition. So a retrosynthetic problem with electrophilic aromatic substitution. So you're going to start with a benzene ring. You need to add 3 things. So the first thing you need to do is look at the relationship between all 3 things. What are they to each other, right? And also think about what's electron withdrawing, what's electron donating, right? So you have 3 things on the ring. I always look for the electron donating ones because those are the ones that direct things anyways, right? So which of these, the nitro, the bromine, or the alkyl is electron donating? The alkyl. And so if it's slightly electron donating, so it directs which positions? Ortho and para. Well, oh, look, the bromine's ortho, and the nitro group is para. Okay. So I probably put these on last, right? The other thing to think about, what's the really bad deactivator? So nitro is a really bad electron withdrawing group that really deactivates the ring. So you probably want to put those on last, right? So one step back would be, what would be the last thing you want to add? The nitro group. So one step back, it would look like this, right? What about one more step back? What's the next thing you want to put? What's the next thing you put on? Bromine. So it would look like this. Here's a little curveball coming at you. How do you put that on? That's a primary carbon. How do you put that on?
The crafts.
It's a Friedel Crafts. Which one?
The AlCl3.
If it's Friedel Crafts alkylation or Friedel Crafts acylation? It has. If you do the alkylation, what happens in an alkylation reaction? What kind of intermediate do you form? You make that super electrophile. You make a carbocation, right? So you need to make this bond right here, right? What kind of carbocation would you need if you broke that bond? You would need a carbocation that looks like that. What kind of carbocation is that? It's a primary. Do we ever make primary carbocations? Uh-oh. So I can't make it by Friedel Crafts alkylation. How else could I make this? That's a benzylic position, right? That's a benzylic position with 2 hydrogens. You could have made it from this. And this could have came from that. So you actually would have started with a ketone. You do a reduction, right? It goes from an electron withdrawing group to an electron donating group. Those are the reactions you know. You need to know.
We need to know.
Yeah. Reducing, right? I showed you 3 ways to reduce benzylic ketones. H2 palladium on carbon, zinc HCl, and H2NN, H2, and sodium hydroxide. Those 3 ways to reduce the reductions of benzylic ketones. So the way it would work, in the forward direction, you would need this acid chloride in AlCl3. I'd put that on, right? That's that Friedel Crafts acylation, right? That's Friedel Crafts acylation. Then you need to do one of 3 ways. I'm just going to do H2 palladium on carbon. That would reduce the benzylic ketone. To put the bromine on, you need Br2 and FeBr3. To put the nitro group on, you need HNO3 and H2SO4. And then it gets you there. So the really hard part was, if I need to have a carbon that's a primary carbon, I can't do it by Friedel Crafts alkylation. I have to first make the ketone and then reduce that. Right? Because if I try to add bromine with this, where would bromine go with the ketone? What position would the bromine go on if I use this one? It would go meta. So I have to reduce this first, make it from an electron withdrawing group to an electron donating group, and then do the reactions, right? So remember those 5 benzylic reactions? Those 5 reactions, the whole point of those reactions was to change the reactivity of the ring. You take something that was donating, make it withdrawing. Take something that was withdrawing, make it donating, right? In this case, we took something that was withdrawing, and we made it donating. So those 5 reactions, that's the whole point of those sets of reactions, was to change the reactivity of the benzene ring. So there's one way to use that. So this is a sapling question about retrosynthesis. So they say you're starting with benzene. So you're going to start with benzene, and you're going to get to something like this. So the question is, how do we do that? Right? So they say it's going to take 2 steps. So you got to look at this molecule and think about, well, what bonds do I want to disconnect first? And you also got to think about as well the relationship to the things on these rings, right? Are they ortho or para or meta to each other? Right? So if you look at this chlorine is in what relationship to this ketone? It's para. Right? This tert butoxide, this O butoxide group is what relationship to this ketone? Para. So then I'd ask you, you've done these super electrophiles. How many ways do you know how to add things to benzene rings with super electrophiles? You know 6, right? Do you know a way to add a chlorine? Yes. Do you know a way to add a ketone? Yes. Do you know a way to add this? No. So this is probably not going to be involved, right? So it's probably this connection over here, I'm thinking. So I look at the chlorine. What kind of if the chlorine is a deactivator or activator? Deactivator. What is a ketone? Is that an activator or a deactivator? Which one's a more deactivator, chlorine or the ketone? The ketone, right? So I probably want to put the ketone on last, right? If something's deactivating, you want to put deactivators on last, right? Because they they slow down the reactions, they deactivate. Put deactivators on last. So that probably means I want to put the chlorine on first. Also, the chlorine directs to which positions? Ortho and, look where this group is. It's para. So that makes sense. So the first thing we're going to do is let's add a chlorine. So we do Cl2, and we could use FeCl3. And that's going to make chlorobenzene. We're going to add one of those. And then if we want to add that ketone piece, we could do that with Friedel-Crafts alkylation. So we take the whole thing, which is an option in the drop-down menu. And we need to add in, FeCl3 again. And that's going to get us to this product right away, right? So we add the chlorine because it's the least deactivating. It directs para, so that would add this ketone piece in that position. And it won't add ortho, probably not, because this is so big and sterics will get in the way, so we'd probably like to add para.